Hello guys, welcome to this video. Today we are going to discuss organic chemistry part 2, where we will be discussing about Iupac nomenclature and isomers. So let's begin the video with the topic isomers. Iso, this word indicates same, something is same. In this case, the molecular formula is same. So isomers is a hydrocarbon. Basically we are dealing with hydrocarbon, so using the term hydrocarbon. Okay, it's a hydrocarbon that will be having the same molecular formula, but the structural formula will be different. This phenomenon is called isomerism. Okay, let's understand isomerism. Suppose I draw 4 carbons, name stands as butane. Name stands as butane. Clear? Okay. This is normal butane. So, what is the formula for butane? C4H10. See here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Clear? So, 10 hydrogen and 4 carbon. This is carbon stated equations. I have not done the hydrogen. Okay. So, since all are in straight chain, whenever all are in straight chain, no one is hanging from here and there. All are in straight chain, it's normal, nothing is abnormal. So it's normal butane, that is written as N-butane. Okay, it's normal, so we will write it as N-butane. Normal butane, not write the word normal, write N-butane. Understood? First isomer of butane is N-butane. Okay. Now, if I draw the structure of butane, instead of this straight chain, if I draw it like carbon, 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 carbon. Now then, is there any change? Formula remains C4H10. So calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do not consider the hydrogen, okay? It is bonded with carbon. Be careful. Otherwise 11 will come. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Clear? C4H10. Formula remains same, but structure is different. This is another isomer. Now, how to remember which isomer? Now see, do you see one hanging on the? One person is hanging. One person is hanging. How to write? 1 in Roman. You write 1 in Roman like this. Small. Okay. Lowercase. So 1 you write like this in Roman, right? 1 in Roman, it is upper lowercase, you write like this. Clear? So you have to remember that whenever there is one person hanging, one carbon hanging, one is there, so write iso. Clear? Iso has also one, that is in the form of I, and one in the Roman alphabet, Roman format is 1 like this. Correct? So this particular isomer is called isobutane. Okay, this is isobutane. Clear? Where one person is hanging, that is one carbon is hanging, we will say it as isobutane. Technique to remember is I small here has in Roman also one is there and one person is hanging. Understood? Clear? Okay. Another isomer is there, but that is not for butane. Butane has got only 2 isomers possible. Okay. Only 2 possible isomers for butane is this. Okay. For pentane there are 3 isomers. Clear? 2. First isomer is N-pentane, that is will be similar. Only 5 carbons will be there. For isopentane also same structure will be there. Carbon will be increased by 1. Clear? 1 carbon will hang down. 4 carbons are the straight chain. Now another isomer that comes in for pentane is, so I'll draw it over here. Comes for pentane is like this. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4 done, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Clear? This type of isomer arises for carbon, for pentane. Okay. This type of isomer will arise for pentane. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Correct. Clear? C5H12 is the formula for pentane. This is correct. Clear? C5H12. C5H12. See, 12 by 12. So what do you see over here? 2% hanging. Correct. 2% is hanging from the main carbon chain. Main carbon chain is this one. 2% hanging on either sides. Whenever you find 2% is hanging, sorry, not is, are, 2% are hanging from the main carbon chain, this type of isomer is called neopentane. It's not fixed. This compound is neopentane. This compound is pentane, so I'm writing neopentane. Might not be pentane, something else. In that case, the respective name. Clear? So this is neopentane. Clear? Whenever you find 2% hanging, it's neo. 1% hanging, it's iso. Clear? If you can remember iso, the other one is neo. Clear? Because normal has only straight chain. Okay. So these are the basic isomers that you need to remember. Now, isomer is a huge thing. Isomer has been divided into two parts. Isomerism, basically, not isomer rather. Isomerism has been divided into two parts. One is that we will study, that is structural isomerism, and another one is a huge part in chemistry, that is stereoisomerism. Okay, stereoisomerism. Okay, this is not there in our syllabus right now. I am not going to discuss also. Clear? Stereoisomerism is a huge topic, so we are not going to discuss about stereoisomerism. Structural isomerism, falling under it is chain isomerism, falling under it is position isomerism, I am writing in short, okay, and falling under it is your functional isomerism or functional group isomerism, and last one in your book is metamerism, correct? Last one in your book is metamerism. Metamerism. More are there, but that's not mentioned in the book. So no need to worry. Yes, more are there, like automerism is there, ringmerism is there. It's not there, okay. So in your syllabus, do not have this, do not have this. We have only this two, but I will discuss this two also. But not this, because that is a huge thing to discuss. Clear? These are not very huge right now. For right now, not, but this is huge. I cannot see very short, okay. Clear? So we are going to discuss this portion, not this portion. This is 3D actually, I have not learned 3D. That is the problem, okay. Okay. So let's begin. Isomer, first one, that is your chain isomerism. Number one, chain isomerism. So as I have already discussed, one carbon hanging from the main chain. If this is the main chain, one carbon hanging, you will say it as iso, correct? Two carbon hanging from the main chain, you will say it as neo, correct? You will say it as neo, correct? So this is the two isomer, that is chain isomer. This is called chain isomer. That is when two or more compounds have a similar molecular formula but difference due to arrangement of carbons in chains. Here this carbon chain is different. If I put this on hold, then this chain is different. Clear? That is what is isomer. Clear? For butane, this is for pentane. Okay, this is for pentane, and this is also for pentane. Clear? Now this is for pentane. Clear? But you cannot write one butane, one pentane isomer. That is not going to be the isomer. They are completely different compound. So if you are told to write isomers, then either you write this, for suppose pentane I am talking about. So this is one isomer of pentane. This is isopentane. Removed one carbon from here, put it over here. This is neopentane. So the compound has to remain same. Molecular formula cannot change. If molecular formula changes, then compound becomes different. There is no more isomer. Clear? Understood? Okay. Next one is your position isomerism. Next one is your position isomerism. Now understand position isomerism. Position isomerism is concerned with double bond, comma, triple bond. This position, it varies, there is a change. Position varying of the double bond, triple bond, it will be causing problems. Clear? Suppose the compound I have taken is butane. Compound I have taken is butane. How many carbons? 4 carbons. Correct? Okay. So C, 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 C. Either you place the double bond over here or you place the double bond over here. Fine. Understood. So let's place the double bond over here. First case. So here, since I have not told you about IUPAC naming it, so relax. Okay. So double bond can be here or here, depending. Both will come same result. Okay. So here we have placed. Hydrogen will be here, 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 here. You can understand that. How many hydrogen? 2 hydrogen. How many hydrogen? 1 hydrogen. How many hydrogen? 1, 2, 3, 4 hydrogen. How many hydrogen? 3 hydrogen. Correct. What is the formula for butane? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Clear? C4H8. Right. can cross check like this. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Achha, this is butyl. So this will be C4H6. Triple bond over here. One hydrogen will subtract. Okay. Clear? C4H6. I'm not taken butene. I've seen butyl. Okay. Anyways, so butyl is there. So triple bond will be there. One hydrogen over here. Looking very weird, right? Let's it over here. Okay. So one hydrogen over here. Second hydrogen over here, third here, fourth here, fifth, sixth, seventh, fifth, clear? Now, the name of this is butyl, and I have already written off butyl. Now, when you write IUPAC nomenclature, butyl word will be accepted, but it's actually where is the placement of this triple bond? Where is the placement between first carbon and second carbon? So it's actually but one ion, clear? But since one we do not write in a specific way, it is considered as one. So omitting one also works, clear? So this is actually but one ion, clear? Now just see formula is C4H6. Now if I change this double bond position from here to here, will that be an isomer? First tell me. I am changing the double bond from here to here. Will that cause any isomer? No. That will also remain as but one in only. Why? Because this and then numbering will start from here. If this is there, clear? That is a thing. Okay. So if you place it over here also, name will remain same. So that's not an isomer. Clear? So for that we need to place this triple bond somewhere else. First one was but one ion. Now carbon, carbon, triple bond, carbon. If I place it like this, now tell me what will happen. Numbering can start from descent. Numbering can start from even descent. Same result will come out. Clear? Okay. Now see the naming will be different. But position between 2 and 3, least locant we are going to take. Which number? Least locant. Who is greater than who is bigger? 3 is bigger. Who is smaller? 2 is smaller. So we are going to consider 2, not 3. Clear? That is what you need to remember. So it's but 2 ion. Now formula remains C4H6. Formula did it change? No. Formula did not change. But this number has changed. This locant has changed. So they are isomers. Clear? This is called position isomer. That means the position of this triple bond is varying from place to place. In this case, we will be saying it as position isomers. Clear? One is but 2 ion, one is but 1 ion. Understood or not understood? This will be applicable for ene as well. Okay. The first one that I showed mistakenly, that in case that if we write instead of butyl, butene, so in that case double bond will be there. One will be here, one will be here. So that will be but 2 in, but 1 in. Clear? Butene and but 2 in. Okay. It's somewhat IUPAC nomenclature. Understood? So this is called position isomerism. That means the position of the double bond, the triple bond will vary. Single bond cannot happen because single bond is everywhere. Okay. Understood? Next one, just know. Next is functional group isomerism or functional isomerism. Generally it's due to the functional group only. So let us keep it functional isomerism. Clear? Functional isomerism. Functional isomerism. This is due to different placement of functional groups. What is the cause? Different placement of functional groups. If functional groups are placed at two different positions, then we will say it as functional isomerism. So let's example. Suppose there is a compound called C2H6O. Clear? Let us keep it the formula is C2H6O. Clear? I have taken one compound, that's formula is C2H6O. Not even a compound, I have just written a formula is C2H6O. Now, this can, someone might say that I will write like this CH3, CH2, OH. Can I put it wrong? I cannot put it wrong. This is exactly correct. This, the name of this is 1, 2 carbon. So eth, and since OH group is added, so it's non, it's ethanol. So this compound is ethanol. Okay, is it wrong? No, it's not wrong. It's very much correct. Absolutely correct. Nothing wrong. Now, someone else can also say, now someone else can also argue In what way he will argue? He will say, if I write this, is it wrong? This is also C2H6O, C2H6O. So what will I do? This is common name is dimethyl ether and IUPAC name is methoxymethane. Correct? IUPAC name is methoxymethane. Right? And this is the common name. Now, this person has written this, one person written this. Can any either of these be marked wrong? No. Both are correct. So this case is functional isomers. This functional isomer, these two are functional isomer. Formula is remaining same for both cases, but functional group presence is in different position, leading to the formation of two different compounds. That is this and this. Formula remains same, but structure becomes different. Clear? Understood? So this is dimethyl ether or methoxymethane. This is ethanol. Ethanol. Okay, completely different. Clear? Formula is same. Structure is completely different. Understood? Clear? Okay. Next one, let's move on to the last type of isomer, that is called metamers. Clear? Phenomenon is meta-isomerism or metamerism, and the isomers are called metamers. Okay. Metamerism. This is basically unequal distribution of alkyl groups on either sides. Unequal distribution of alkyl groups on either sides. Let us take C4H10O. Clear? Let us take C4H10O. What is the compound I have taken? C4H10O. Formula is C4H10O. Understood? Now, someone might argue that we can write like CH2, how many are left? C3H7. Okay. Someone might argue that I can write like this. Fine, it's completely relaxed, it's fine. What is the name? Name is methoxy propane. Fine. Absolutely correct. Nothing is wrong in this. Now, if someone argues to write it as C2H5O and C2H5, what will I say? Both. This is also correct. This is ethoxy ethane. Correct. This is ethoxy ethane. This is also correct. This is also correct. Formula is also same, but unequal distribution. Distribution is different. This is isomers. This is metamers. Clear? Metamers. This distribution of alkyl radical on either side is different, due to which isomers arise. This is called metamers, where this alkyl radical on either side is distributed unequally. Here you see CH3 and here on this side another is there. This is basically 3 carbons, so this is propyl. One is methyl, one is propyl. Here one is butyl, here is one ethyl, this is also ethyl. Ethyl, ethyl, methyl, and this is propyl. Understood? Clear? Understood? So this is unequal distribution of alkyl radical on either side, causing meta-isomerism, that is metamerism. Clear? So that was all you need to read from isomerism portion. Okay? Now we are moving on to the most important part, that is IUPAC nomenclature. Okay? IUPAC nomenclature. Basically, there are many common names in the different parts of the world. Maybe we are saying something else, some other country is saying something else, whom will we listen to? Therefore, IUPAC name has been fixed for the entire world. Wherever you are, this name is accepted, and this name is allotted to only one specific compound. Okay, there cannot be, like if I write but one ion, there cannot be someone else with the same IUPAC name. No, name has to be different. Okay, name cannot be same of two IUPAC compounds. Clear? So how will you name a compound? How will you name an organic compound? There are steps to name an organic compound. So let's begin with the first basic step. Very first basic step. Whatever compound is given, you check the root words. You check the root word there and write the number of carbon atoms. Before writing that also, let me tell you that nomenclature contains three parts. One is your prefix, number two is your root word, number three is your suffix. Clear? These are the three things that you need to keep in your mind for now. Prefix is secondary, primary, secondary, primary, that's different thing, not now. Prefix, root word, suffix. Three things you have to keep in mind. Clear? I have written this in order as well so that you can remember it. Clear? Root word, suffix, prefix. Prefix you can understand will come before root word, suffix. Suffix will come at the end. Clear? Root word has to be in the middle, prefix will be before the root word, and this suffix will end. Root word is suppose let's say prop, suffix is end, so it's propane. Clear? And if before it's cyclo, then put cyclopropane, right? Cyclo will become the prefix, but we are not having cyclic compounds, so no need to worry about that. So you have to remember that an organic compound name will contain three parts: prefix, root word, suffix. Clear? Now, suppose let us take one compound is given to you. Let us take one easy one. Let us take its pent 2 all. Clear? It's given pent 2 all. How will you approach towards this compound? To approach it, you need a basic rules. First and foremost rule, check what is the number of carbon atoms that is given in the compound. It will not be written to you that this number of compounds. You have to find out from the name. What is the word saying? Pent. Pent indicates how much? 5. So we need to draw 5 carbons on the first straight chain. Later on we will see what chain will come. Straight chain. Clear? Straight chain, 5 carbons done. Next thing. All is there. All is there. Now you will think, is it single bond or double bond? Now whenever nothing is mentioned, you will take it as a single bond until and unless there is something in or in mentioned. Clear? Generally you will not get this type. It will be mentioned like pentan 2 all. In that case also you have to check that this an indicates alkane. Clear? This also indicates the same thing. So for now single bond. Clear? So pentan 2 all, it's single bond all. Now we have been specified the position of all. So now you have to see, whenever there is a number given in the question that indicates the position of the following number, following whatever is given. Right? 2 is given, following 2 whatever written, all indicates alcohol group, functional group alcohol. So that means that OL, that OH is present at that particular position. That is this position, second position. Now the thing comes up. Where to place this person? Numbering has to be done. So you can number it like this: 1, 2, 3, 4, 5, or vice versa. You can number. It's fine. Absolutely, it's fine. You number it from this side. You number it from this side. But generally, I will prefer numbering from this side. Okay? Generally, I will prefer numbering from this side. But you can do it from this side also. There's no problem with it. Right now, no problem. Clear? So you can number from this side. You can number from this side. I am numbering from this side. So this becomes my first carbon. This becomes my second carbon. This becomes my third carbon. This becomes my fifth carbon. This becomes my fourth carbon. This becomes my fifth carbon. Correct? Where is this location? Second. So where is second carbon? If you label from this side, second carbon will fall over here. I have labeled from this side, so second carbon falls from here. So here I will write OH. Understood? Now remaining satisfying balance sheet I will do. So here 3 you will satisfy, not satisfying. Okay. So here 1, 2, 3. So more 1 will be over here. Here 1, 2, 3, 4. Here 1, 2, 3, 4 done. So here 1, 2, 3 done. So this is what? Pentanol. Understood? Pent 2 all or pentan 2 all. How to do that? Approach is basic this. So first rule that you have applied, you have written the carbon skeletal equation. Then second rule, numbering you have done. Start from the left side or right side. Numbering you have done. Clear? Numbering you have done. Now, this was an easy one. Now what if a random structure is given? What would you have done? This is drawing the particular structure. But what if a structure is given? That also we will do. First let us understand how to draw a structure from this. Name is given, draw the structure. First step, draw the full carbon skeletal equation. Understood? Then wherever this number is mentioned, see the following number. see the following thing. Following is OL. OL indicates alcohol, that means OH group. So OH group, where you will attach? Second carbon. Where is the second carbon? Here. So you have attached it over here. Clear? This is the basic thing that you need to check for drawing a structure from a given name. Clear? We will do more, no need to worry about that. Okay. Now, how to get a name from a given structure, the vice versa. This is the name you have done, right? Now, how to get a name? How to get a name from a given structure? Suppose I give you a structure. Let us take. You have drawn neopentane already. So neopentane was like this. Correct? Hydrogen. So instead of neopentane, you already know it's neopentane. So I give like this. Clear? I give like this. See, 1, 2, 3, 4, 5 carbon, 3, 3, 6, 3, 9, 3, 12. Clear? So it's a neopentane structure only. Nothing else is coming. But you have to identify the name. How will you identify? First step approach. Parent carbon chain needs to be selected. Now there is no hard and fast rule that the selected carbon chain always has to be a straight one. No, there is no need. It can be a bent chain as well. Depends on which is the structure given in your question. Clear? It can be a bent chain. You have to take the maximum carbon chain as the parent chain. Wherever the maximum carbon is placed. Suppose here too, wherever you take is 3 carbon. You take like this 3 carbon. You take like this 3 carbon. You take like this also 3 carbon. Take like this also 3 carbon. Wherever you take from this, 3 carbon is there. But it's not always like this type of structure will be there. Can be other structures where from every corner different number of carbon atoms is coming. So you will take wherever there is a maximum number of carbon atoms. Understood? Exceptions are there. Exceptions will arise. What is the exception will arise? Lot of exceptions. Here, instead of CH3, if I add OH over here, then which carbon chain will you take? This one? No, you cannot take that carbon chain. Whenever there is a functional group present, the carbon chain will be the main chain that contains the functional group. Clear? Exceptions are there. Here, instead of CH2, I have put OH. What I have put? OH. OH is what? Alcohol. Alcohol is a functional group. So, whenever there is a functional group, you cannot take this as a main chain or this as a main chain. You have to include this in the main chain. Have to do it. You have to include this in the main chain. Clear? So, in that case, this becomes the main chain. Understood? Though it has less number of carbon atoms, I accept it. It has less number of carbon atoms. But yet, whenever there is a functional group, you have to include that in the main chain. Okay? So, let's put back CH3 over here. So, first step is selecting the parent carbon chain. So, let us select this straight chain. Straight chain selected as the parent carbon chain. When we are drawing the structures from a name, we had taken numbering. Number this also. Number this also. Again, you have to keep in mind, you have to number in such a way that the substituents will get the least locant. Here you name from this side will also get the same number. Locate from this side also same number. So in this case no problem. But cases will arise where you have to name from one end, otherwise it will get a higher number. You will get to know these varieties when you come across those questions. Clear? So you can name from this side, you can name from this side. Now what do I mean by locant? The position. The number you are assigning at which position it is located is locant. Clear? It's a locating position. It's a locant. Clear? That has to be the fluid. Now what is a substituent? I use the term substituent. What is that? Substituent is anything that is attached to the main chain. Under anything, it can be anything attached to the main chain. Anything attached to the main chain is a substituent. In this case, these are substituents. These two are substituents. Clear? Whatever is assigned to the main chain is a substituent. Understood? If main chain is carbon, 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 and here something is something Y is attached, then this Y is a substituent. Clear? Anything it can be. Y can be anything, but not a functional group, because functional group has to be attached inside. Correct? The group has to be attached inside. Understood? Clear? So first step was we have checked the parent carbon chain. Second step we are numbering it. So let's number it. 1, 2, 3. Second step over. Number done. Second chain done. Numbering done. Correct? Okay. Next, we have to check the substituents are attached to which particular position. Which particular position? See properly. This particular substituent is added to which position carbon? Number second. This also at second. So how will you write the name? Name, if two positions are there, then separate them by a comma. First let's write this one. What is the locant? 2. Another locant is there, you cannot write 22, that is not possible. Clear? So you have to separate that by using a comma. So we use 2, comma 2, another 2, 2 for another this methyl. Next we'll put a hyphen so that we can identify, understand that these two 2's are for this particular two things. Clear? To put the hyphen in between. Understood? Even when you put but 2 ine, you put a hyphen in between so you can understand that 2 is for ine. You have to put that hyphen. Clear? 2, 2. Next, how many methyls are there? 2 methyls are there. 2 stands for di. In chemistry, we write di, right? Di for 2, tri for this, tetra for this, pen for that, going on. So that's di. So we'll write di. What is the alkyl radical? Methyl. So we'll write di methyl. Now the thing comes. What is the number of carbon atoms in the main chain? I am not bothered with all the carbon atoms. I am not bothered with this carbon atom because they are not the part of main chain. I am bothered with only the main chain carbon atoms. How many main chain carbon atoms? 1, 2, 3. 3 stands for root word prop. Correct? So I am writing prop. Next, all are single bonds. Any double bond presents? Any single bond? Any triple bond present? No. Single bond only. So what will be the suffix? N. So what does the name stands as? 2, 2 dimethyl propane. Clear? This is neopentane. This is neopentane. But if you write neopentane big 0, IUPAC name is not neopentane, it's a trivial name. Right? Clear? So 2, 2 dimethyl propane is this neopentane's IUPAC name. Repeating, how did we get it? First step was that you have to identify this main chain. After identifying the main chain, you will have to number the carbons. You have to number the carbon seeing the substituents. Seeing the substituents. If any functional group is present, that has to be included in the main chain. That has to be included in the main chain. Be it less carbon, but you have to include it. Clear? Clear? If there is no functional group, then you have to check for the longest carbon chain. Whenever the carbon chain is carbons are more, you have to take that chain. That might not be a straight chain. That can be a bench chain. Any type of chain. Clear? Branch chain, bench chain. Clear? After that, number the carbon properly. You have to take proper care that these substituents will get the lowest locant. We will come across questions where you will find that these problems will arise. In that case, you have to think properly and answer. Clear? Understood? So this substituent must get the lowest possible locant. Then we will be seeing that to which carbon this substituent is attached, is or are attached. Clear? Here both are attached to the same carbon. It is this number we have done is second. So we are writing 2. First 2 for this, second 2 for this. Since two things are being added, so we are writing 2. More are added, then we write more. Okay? Though more cannot be added. So 2, 2. Then we have put a hyphen to indicate that these two values are for this. Then we are writing hyphen. Then we are giving di. Why di? 1 methyl, 1 methyl. 2 methyl, 2 methyl. So we cannot write 2 methyl. So we are writing di methyl, dimethyl space. Prop for how many? 1, 2, 3. 3 carbon. Prop done. All single bonds presents. N done. The name comes out to be 2, 2 dimethyl propane. This is the thing that you need to recall. Everything is filled up with this part. Rules if you can remember, no problem in naming. Rules if you can remember, no problem in naming. Understood? Next, let me just modify this question. Just modifying one part of this question. Instead of CH3, if I write over here C2H5, what will happen? Just modified one part of the question. Erase this. Modifying one short part of the question. Okay. C2H5. Here one carbon was supposed to be there. Here CH3 was supposed to be there. Here also CH3 was supposed to be there. Here also CH3 was supposed to be there. Correct? Now I have just modified this part. We have not written a CH3 over here, but instead of that we have written another thing, that is ethyl C2H5. Now what changes can you get? Understand the thing properly. Here you cannot take the main chain as this. Now tell me why. Why we cannot take the main chain as this? Check properly. C1, 2, 3 is possible. Any functional group is present? No. No functional group is present. So we have to take the longest possible chain where carbon number is maximum. Is the carbon number maximum over here? How many? 1, 2, 3. Is here 3 coming? 2, 3, 4. 4 carbons are possible over here. Here also 4 carbons are possible. Here also 4 carbons are possible. That you can do. But this is better, so I am just taking it. Clear? You can take like this also. You can take like this also. Or you can take like this also. Same thing. Clear? But you cannot take straight chain. Or you cannot take this type of chain. Clear? Or you cannot take this chain. Why? Because carbon are more possible over here. Why will you take that smaller? You cannot take smaller until there is a functional group. No functional group, cannot take smaller. So what will be the main carbon chain over here? This will be the main carbon chain. Need not be only straight. It can be, if you want to bend it, yes, you can bend it. But this has to be included. Clear? Without this, no parent chain is possible. So this is the thing that you have to remember. This is the thing that you need to understand. Here, maximum carbon chain, parent chain we have taken. Maximum number of parents, carbon atom we have taken as the parent chain. Right? We have not taken this as the parent chain. Why? Reason is carbon is less in number. Now the next thing, numbering. Numbering you can do from here or from below. So 1, 2, 3. 3 carbon. Done. 1 carbon, 2 carbon, 3 carbon. Clear? Now let's see. How many carbon present? 1, 2, 3, 4. So I am writing this side first. Clear? So let's see. It's but, all single bond. So N butane. Now first part. How many? 2, 2. Same thing. First part will not change. Okay. 2, 2. Then it's dimethyl butane. Clear? 2, 2 dimethyl. This word has changed due to addition of this particular thing. Clear? Due to addition of this particular thing, we have changed the name to this and this. Understood? So we have taken this as the main chain compound, these two are the substituents, and that will give you the answer. Clear? Now here, ethyl will not come in the name. Why? Ethyl is already taken in the main chain. You cannot write ethyl again. And if you ignore ethyl, then this part will only not come. Because you cannot ignore ethyl, you cannot make ethyl a substituent. You have to put ethyl in a parent chain, right? Because that will fetch you more number of carbon atoms than others. Place it like this and ethyl as such, then you have to write ethyl. But that will not give the correct IUPAC name. Because ethyl, if you add in the parent carbon chain, then you will get more number of carbon. That is what we want, right? That you have to see, you have to interpret properly, and you have to get around to the proper result. Clear? Understood? This type of tricky questions will be asked. Okay? Will be asked. So you have to check it. Okay? Now let's do one question. I will do the exercise, that is for sure. Let's do one question. The question is CH3 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 CH2 CH C2H5 and here is CH2OH. Okay, this is a question that has been told to write the name of this compound. Now seeing everything will be baffled like what is happening, why it is happening, but you will have to understand first what is happening. Now see, we need this particular thing to be put in the parent carbon. So you can understand this is alcohol. So we need this particular thing to be put in the main carbon chain. Now you have to check which will provide you more number. See, putting the straight chat, you have to first hit and trial and check it, right? Suppose I put in this straight carbon chain. Now let's check 1, 2, 3, 4, 5. How many? 5. 5 carbon possible from this side. Okay. Now let's take from this side. 1, 2, 3, 4, 5 carbon. Fine. Let's take from this side. 1, 2, 3, 1, 2 is already there. So 4 carbon possible. So this is 4 carbon. This is 5 carbon. This is 5 carbon and this is also 5 carbon. So you can see that 2 carbon chains give you the same answer. 2 carbon chains give you the same answer. So we will be taking either of those. This also if you take, this will be remaining as substituent. This also if you take, will remain as substituent. So you can take either of this or this. Clear? Both will give you the same answer. Understood? So I am taking this one as the main carbon chain. This one. This one I have to take as the main carbon chain. Acha, now I have told you that the substituent should get least locant number, right? That was when we are adding it. Now, functional group presence, double bond presence, triple bond presence, that should also get the lowest possible locant. Is understood? If a double bond is present, if a triple bond is present, or if any a functional group is present, all should get the lowest locant number. Now you will say, if all are present in one, then what will we do? Functional group has the highest priority. Functional group will have the highest priority, then double bond, and then at the end whatever end is their substituents. Clear? First priority you have to give to functional group, then to double bond, triple bond, then at the end is the substituents. Clear? Understood? So who is present over here? Mr. OH. So OH will be given high priority. So we will be starting the naming from this side. 1, 2, 3, 4, 5. How many? 5 carbons. Main chain. 5 carbons. Clear? Now the thing comes. Who to write at first? Methyl or ethyl? In this confusion, whoever is alphabetically ahead, write that. Alphabetically, whoever is ahead, you write that. Computer you have done lexicographically. True that lexicographically. Even if the first alphabet matches, true that second alphabet and check. Clear? But whoever is alphabetically ahead, you have to write that. Who is alphabetically ahead? M or E? E. So you write E first. So wherever is E attached? 2. So we are going to write 2 ethyl. This is ethyl, correct? So it's 2 ethyl. Next, comma. Separating the constituents, comma has to be there. Clear? 2 ethyl. Next, comma. This particular constituent has to be written. These are all prefix too. These are all prefix. So this has to be written. Then where is it attached? 4th carbon. So it's 4 methyl. Correct? 4 methyl. Understood? 2 ethyl, 4 methyl. This is 4th carbon. So we are writing 4 methyl. Correct? Next, whenever you are writing the next part, root word, no comma has to be there. Please. Prefix separation, comma. But after prefix, when you are writing the root word and then suffix, there should be no comma in between. Make sure about that. Clear? If you write comma, then whatever you write, that will not work. Comma, yes, another prefix is there, fine, then the comma is okay. But if it no prefix, we will not keep comma, right? Next, all prefix done, all substituent done, no more substituent to write, no more prefix to write. Next, we are going to write a root word. Let's see how many carbons? 5 carbon. Root word, pent. Comma will be there? No. So no comma, pent. Next, let us check. We have a functional group at the end. Be careful about that. Functional group at the end. Where to place the functional group? First position. So writing one and not writing one is equivalent, but always go for the safer path, that is write one. Write one. No one will say you anything. Write one, no problem. So it's pent 1 all. Correct? 2 ethyl, 4 methyl, pent 1 all. Naming is complete. Very difficult. Very difficult. No. You have to just identify. To just interpret properly. How did we interpret? We did not take any other parent chain because this parent chain was giving the same result, this also same, and it's always better to take a straight chain than a bent chain just for visualization. Clear? But you cannot check this one because it's very short. Understood? Now, since we have taken this as the main chain carbon compound, this particular naming starts from over here. Why? Because we are giving high priority to functional group. It is a law which, not a law actually, rule, which states that this particular functional group will be given the highest priority, then double bond, triple bond, and the last is the subsequents. So we are giving high priority to this person, that is being numbered as 1. Next, going on like this. Clear? So we are seeing 5 carbons in the main chain. So we have written pent here. Clear? Pent here. Now you will find pentan written somewhere. You will find pent written somewhere. You generally go for the safer way. So instead of writing pent, let us write pentan only. Okay? Because it might be cut. Okay, so always go for the safer way, that is pentan. Okay, do not write pent. Okay, write pentan 1 all. Clear? Always separable. No need, no scope of cutting marks. Write pentan. No one will deduct any mark. Do not go for pent. Okay? Write pentan. Okay. So how many? 4. What are we writing? Pentan. Because we cannot write n at the end, right? N all is nothing. N all. What is n all? Nothing is n all. So we cannot write n all at the end. So we are writing an before. Okay. Okay. Done. We have written here all position 1 pentan because 5 carbon. Done. Coming to before. First methyl, ethyl. Which one to write first? Ethyl. Alphabetically E comes before it. We have written ethyl first. E is small. 2 position Y because this ethyl is added at second carbon. Naming done. Numbering done. Second carbon we are seeing this is attached. So we are writing 2 hyphen ethyl. Then comma because prefix we are separating. Okay. Methyl attached to the 4th carbon. So 4 methyl. Then whatever is there. Understood? So naming has to be done in a proper order, in a proper way. That is in this way. So you have to make sure that you interpret the question properly and you write the answer correctly. Okay? Drawing structures and writing answers. These two are very important and question will come on writing and naming structures. Clear? Now, suppose this name is given to the question. The last part for today, for this video, the last thing I want to say is that suppose this name is given to you. Okay? Let me copy the name. It's 2 ethyl, 4 methyl, pentan 1 all. Correct. Now if this name is asked, given, and it is asked to draw the structure. How will you approach? As I have already said before, you will draw the carbon skeletal first. No matter what happens, you draw the carbon skeletal first. How many carbon we need? Pentan, 5 carbons. 5 carbons. 1, 2, 3, 4, 5. 5 carbons done. Shift a little bit over here. C, 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 C. Done 5 carbons. Ended. All is there. Attach it either to this side or this side. I am adding it to this side for my safety. If you are adding on this side for class 10, it's perfectly okay. In 11, 12 you might face problems. Always keep it on this side. Just a suggestion, okay? So I am putting it over here. So here I can put OH. Here I can put OH. So I am putting OH over here. Now OH cannot be bonded with directly with this carbon. Can OH be bonded with directly with carbon? No. Someone else has to be there to bound with carbon. So who is there? CH3 is there. With this carbon, with that OH is being added. Correct? This carbon is being satisfied by hydrogen. So that is be satisfied this oxygen, alcohol. Clear? This is CH3 satisfying this particular person. Understand? Carbon was there. We are satisfying the valency test first. Hydrogen. Let's not write hydrogen immediately. Carbon is there. So we are writing this particular bond line is empty right now. Clear? So here automatically CH3 becomes, understand the thing, automatically a CH3 will become over here. With that CH3 and OH will be added. So already CH3 is present. Put the CH3 then OH will be there. So we are writing CH3OH. Clear? Abbreviated formula, right? That's CH3OH. So here is CH3OH. Understand it. Then numbering starts from this side. So 1, second carbon ethyl. So here already person is present. Who is present? CH2 is present. CH2 is already present. So with this CH2 add C2H5. No problem is there. Clear? Understood? I add here C2H5. Understood? Add here C2H5. Then we are moving on to the 4th carbon person over here and we will be adding CH3 over here. Clear? Numbering and this naming is very important. Clear? Numbering and this naming is very important. Okay, now if this is sounding very confusing, it might sound confusing at first. So let's do it in another easier way. Where you will be just drawing this. Just drawn this. Done? Numbering starts from here. 1, 2, 3, 4, 5, 5. Written. All is over here. Write OH. For now OH only. Clear? For now OH only. Yes, right? For now OH. For now I am talking. Okay, OH. Methyl is added at 4th position. So here let us add CH3. Here second ethyl. So it's ethyl C2H5. Written down. Okay, below and upper position is same. Clear? So here I am adding one hydrogen. That's now I am satisfying the valencies. Students, understand? Satisfying the valencies over here. Clear? 2 bonded done, 1 more bond over here. 1 more over here. 2 more done, 4 done. Here 4 done. Here 3 more. Done. This is valency satisfied. Clear? Understand now. Now you condense the formula, you will get the same thing as you got previously. Here you will get CH, where is it? CH, H3. Clear? CH bonded with HCH3. Here also CH bonded with C2H5. That was there in the previous structure. Clear? Understood? So you have to check for the proper diagram. You have to check for the proper thing that you need to answer. You need to check for properly. This is a diagram. Clear? This diagram will also give you marks. That is abbreviated diagram. This is your expanded diagram. What is the difference? Same difference. Same thing. If that previous thing was confusing, draw it in this way. It's very easy. Understood? Understood or not understood? Understood? Repeating again. I'm repeating again. I'm drawing a better diagram. Repeating again. I'm drawing a better diagram. Suppose this name is already there. So C, single bonded C, single bonded C, single bonded C, single bonded C. I told you to draw this first of all. Then first number it. Simple. 1, 2, 3, 4, 5. Number it. Clear? Now just add wherever the position says. Where it is saying? All. Number 1. Added OH temporarily. Next pentan we do not add anything. 4 methyl. Where is 4? Here. Added CH3. Then says 2 ethyl. Ethyl over here C2H5. Now everything added. Now satisfy the remaining valencies. Remaining valencies. Here 1 valency done, 2 done. How many more? 1 hydrogen, 1 hydrogen. Clear? Okay. Now I am putting this above. Okay. I am putting this above. C2H5. Okay. 4 done. How many? 3 done. 1 more. 8. Okay. Here 1, 2. 1 more. Not 1 more. 2 more. Here 1 done. 3 done. 1 more. Done. And here 1, 2, 3. Done. Now condense it. Condense the formula. CH3. Then you are getting CH. CH. This CH is bonded to CH3. Then you are getting CH2. Then you are getting CH. Which CH is bonded to C2H5. And you are getting a CH2OH. Wasn't this the formula that you had worked out to get this name? Wasn't this the thing that had been given for you to identify the name? This structure has been given, right? And this structure. Understood? So from this similar name you can get this structure, which in condensed structure is this. So things are like this. It will be given in condensed structure. You will have to expand it in some case. In some case it is given to expand it. Just contact it. Understood? It might be told, name this type of compound. If it is very hectic, it is very hectic, compress it. Like I have compressed it like this. Now it's better to easier to identify this name than from here. Hectic. So write like this. Clear? So that depends on your ability to interpret. And I know that you all have a good ability to interpret. So you all can do IUPAC nomenclature. In the next video, I will be discussing about the exercise of the nomenclature that is given in your book. So stay tuned. See you all in the next video.